Hello, in this lecture we'll answer on two questions. In the first question, we'll find out the area of the blue shape, and in the second question, we'll find out the radius of this circle that blocks triangle ABC. So we'll start with the first question. First of all, we will define the center. We have in the drawing a big circle. The radius of the big circle is equal to 13 units, and AB is the diameter of the big circle, and triangle ABC is inscribed by the big circle, and triangle ABC itself blocks the small circle. So the small circle is inscribed by triangle ABC, and the radius of the small circle equals to 4 units. And we want to find out the area of the blue shape. So first of all, we will define the center of the small circle as O. And we will also define the point of tendency of tangent CB with a small circle as point M. We define the point of tendency of tangent AC with this small circle as point N. And we define the point of tendency of tangent AB with this small circle as point L. In the next step, we will join points O and M together by a straight line. Point O is the center of the small circle. Point M is a point on the small circle itself. This is exactly the definition of a radius. So OM is the radius of the small circle. So we define the radius of the small circle as R, and R equals to 4 units according to what is given as the question. We will join points O and N together by a straight line. Point O is the center of the small circle. Point N is a point on the small circle itself. This is exactly the definition of a radius. So OM is also the radius of the small circle, that is equal to 4 units. We also have actually rule number 1, and according to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent CB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Likewise, we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent ON with this small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO, which means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. And we also have the peripheral angle ACB. This is angle ACB is a peripheral angle, and it rests on side AB, and side AB is the diameter of the big circle, and we have the rule that any peripheral angle that rests on the diameter of the circle equals to 90 degrees. Therefore, peripheral angle ACV that rests on the diameter of the big circle, which is to say it rests on side AB, that is the diameter of the big circle, must be equal to 90 degrees according to the rule that I mentioned. So actually, in quadrilateral ONCM, we have 1, 2, 3 right angles. Again, quadrilateral ONCM, we have 1, 2, 3 right angles. So I'll write it down. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MON. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle MON, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So this angle, it is a right angle, it is equal to 90 degrees. So actually we found out that inside quadrilateral NOCM, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral ONCM as a rectangle. So quadrilateral ONCM, it is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of a rectangle ONCM, they are equal to each other. That is to say, NO equals to CM. NO equals to CM according to the rule that the opposite sides of a rectangle are equal to each other. Okay, NO equals to CM. But we have already found out that NO equals to 4 units. So we can write here that NO equals to 4 units. And from this equation, 4 equals to NO equals to CM, we will derive that CM is also equals to 4 units. CM equals to 4 units. So I can write here that CM is equal to 4 units. Likewise, according to the rule that the opposite sides of rectangle are equal to each other, we get that OM equals to NC. OM equals to NC. But we have already found out that OM equals to 4 units. It is the radius of the small circle. So OM equals to 4 units. And from this equation, 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. NC equals to 4 units. So here NC equals to 4 units. So actually found out that quadrilateral NOCM, it is not a rectangle but a square because of the fact that all of its sides are equal to each other. Okay, so in the next step we will define side AC of triangle ABC as A. Side AC equals to A according to our definition. AC equals to A. We define side CB as B. Here, CB or BC equals to B according to our definition. And we define side AB, that is the diameter of the big circle, as C. Here, side AB equals to C according to our definition. Okay. I repeat again. Side AC equals to A, side CD equals to B, and side AB equals to C according to our definition. So, what is the length of side AN? From drawing it is very easy to see that AN equals to CA minus CN. CA minus CN equals to AN. So AN equals to CA minus CN. I'll repeat again, and AN equals to CA minus CN. So AN equals to CA equals to A according to our definition, minus CN equals to 4 according to what we have already found out. So in conclusion, we found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. Likewise, we find out the length of line segment MB. It's very easy to see from the drawing that the length of line segment MB, it is equal to CB minus CM. CB minus CM equals to the length of line segment MB. MB equals to CB minus CM. So MB equals to CB and CB equals to B according to our definition, minus CM. CM equals to 4 according to what we have already found out. So in conclusion, we found out that MB equals to B minus 4. MB equals to B minus 4. In the next step, I will present to you a new rule. It is not a new rule, but it is rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So here, we will focus on the common external point, point A, from the common external point A, this point, we have two tangents to the small circle. The first tangent to the small circle is AL, and the second tangent is AN, and according to rule number 2, they are equal to each other. So here AL equals to AN according to rule number 2. But we have already found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. And for this equation AN equals to A minus 4, we will derive that AL is also equals to A minus 4. AL equals to A minus 4. AL also equals to A minus 4. So on the next step we will focus on the common external point B. From the common external point B, we have two tangents to the small circle, tangent BL and tangent BM. And according to rule number 2, the lengths of those two tangents are equal to each other, that is to say, BL equals to BM according to rule number 2. But we already found out that BM equals to B minus 4. So we can write here that BM equals to B minus 4. And from this equation BL equals to BM equals to B minus 4, we will conclude that BL is also equals to B minus 4. BL is also equals to B minus 4. We can write down here that BL equals to B minus 4. So in conclusion, we found out that BL equals to B minus 4 and AL equals to A minus 4. In the next step, so actually we know that AB is the diameter of the big circle, and the diameter of any circle is twice as long as the radius. So if the radius of the big circle is defined as R, then the diameter AB of this circle will be equal to 2R. But it is given us the question that the radius of the big circle equals to 13 units, so R equals to 13, therefore AB, that is 2R, will be equal to 13 times 2 is 26. Okay, so AB equals to 26, so AB but also equals to C, so C also equals to 26. Okay, so yeah. So for one side, AB equals to 26 units. But from the other side, from the drawing, it is very easy to see that AB equals to AL plus LB. AB equals to AL plus LB. AB equals to AL plus LB. So, according to equation number 1, AB equals to AL. We already found out that AL equals to A minus 4. AL equals to A minus 4. And LB equals to B minus 4. So let's substitute LB by B minus 4. So in conclusion, I found out that according to equation number 1, 26 equals to A minus 4 plus B minus 4. That is to say it is equal to A plus B minus 4 plus minus 4 is minus 8. So according to equation number 1, 26 equals to A plus B minus 8. Here we add to this equation number 1, 8. And we'll get that according to equation number 1, A plus B equals to 26 plus 8 is 34. A plus B equals to 34. So here we'll square both sides of this equation number 1. And we get that according to equation number 1, A plus B squared equals to 34 squared. So here we will open the brackets on both sides of this equation number 1. And we get that A plus B squared equals to A squared plus B squared plus 2 times AB, and it is equal to 34 squared. 34 squared equals to 1156. So according to equation number 1, A squared plus B squared plus 2 times AB equals to 1156. In the next step, we will focus on the right triangle ABC. In the right triangle ABC, by PT is the abbreviation for Pythagoras theorem. In the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AC squared plus CB squared. I repeat again. In the right triangle ABC according to the Pythagoras theorem, we get that AB squared equals to AC squared plus CB squared. So according to equation number 2, we get that AB squared equals to AC squared. AC equals to A, so AC squared is A squared. Plus CB squared. CB equals to B, according to our definition, so CB squared will be equal to B squared. So here we got that AB squared equals to A squared plus B squared, but AB equals to C according to our definition, so We substitute AB by C and we get that according to equation number 2, C square equals to A square plus B square. Okay, I'll repeat again. According to equation number 2, we found out that C square equals to A square plus B square. But we've already found out that C equals to 26. So C square will be equal to 26 squared, that is 676. So in conclusion, according to equation number 2, we found out that 676 equals to A square plus B square. And because of the fact that A square plus B square equals to 676 according to equation number 2, we'll substitute A square plus B square in equation number 1 by 676 from equation number 2. We'll do it now, we'll get here. That according to equation number 1, we have here A square plus B square that is equal to 676 according to equation number 2 plus 2 times AB equals to 1156. So according to equation number 1, we found out that 676 plus 2AB equals to 1156. Here we subtract from this equation number 1, 676. And we get that according to equation number 1, 2 times AB equals to 1156 minus 676 equals to 480. So we found out that according to equation number 1, 2 times AB equals to 480. We divide this equation number 1 by 2. And we get that according to equation number 1, A times B equals to 480 over 2 is 240. We divide this equation again by 2 and we get that AB over 2 equals to 240 over 2 is 120. So we found out that according to equation number 1, AB over 2 equals to 120. But what is the area of the blue shape? From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So it is the area of triangle ABC minus the area of the blue of the small circle. I'll repeat again, from the drawing it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So the area of the blue shape equals to the area of triangle ABC. The area of triangle ABC equals to the base of the triangle that is AC times the height to the base that is CB over 2. Okay, again, the area of triangle ABC equals to the base of the triangle that is AC times the height to the base that is BC over 2. The height creates 90 degrees with the base AC, therefore CB it is indeed the height to the base AC. So minus the area of the small circle. The area of the small circle equals to pi r squared and r equals to 4 units, this is the radius of the small circle. So in conclusion, we found out that the area of the blue shape equals to, if AC is A, times CB, CB is B, over 2. So the area of triangle ABC equals to A times B over 2, minus the area of the small circle. The area of the small circle is pi r squared, and r equals to 4. So r squared is 4 squared, that is 16. So in conclusion, the area of the small circle equals to 16 pi. So actually we found out that the area of the blue shape equals to the area of triangle ABC, that is actually A times B over 2, but we already found out that A times B over 2 is 120, so we substitute AB over 2 by 120 minus 16 pi. So in conclusion, we found out that the area of the blue shape equals to 120 minus 16 pi square units. So in terms of numbers, it is equal to 69.73 square units. Okay, next step, we will solve the second question in three different methods. Okay. So here in the drawing we have this circle, and we also have triangle ABC that is inscribed by this circle. We know that the area of triangle ABC equals to 9 square units. Side AB of triangle ABC equals to 5 units in its length, side BC equals to 6 units in its length. And we want to find out the area and the radius of this circle that blocks the triangle ABC. So we start with the first method. So here from point A, we will draw perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees. According to our construction, we define the touching point of the perpendicular from point A and BC as D. So actually note that the area of triangle ABC equals to 9 square units. So I can write down here that the area of triangle ABC equals to 9 units, but the area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is AD, over 2. Repeat again, the area of triangle ABC equals to the base BC times the height AD over 2. BC equals to 6 units according to what is given as the question, so it is 6 times AD over 2. So according to question number 1, we found out that 9 equals to 6 over 2 is 3 times AD. Here we divide this equation number 1 by 3. And we get that AD equals to 9 over 3, that is 3. We found out that AD equals to 3 units. Here we can write down that AD equals to 3 units. In the next step, we'll focus on the right triangle ABD. On the right triangle ABD, according to the Pythagoras theorem, by PT is the equation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared. That is equal to the sum of the squares of the perpendiculars. That is to say it is equal to AD squared plus BD squared. We repeat again, the right triangle ABD, according to the Pythagoras theorem, we get that A squared equals to AD squared plus BD squared, so AB equals to 5, so AB squared is 5 squared, that is 25, and it is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus BD squared. So here we subtract 9 from this equation number 2, and we get that according to equation number 2, (25 minus 9 is 16, so 16 equals to BD squared. Here we take a look out of this equation number 2, and we get that according to equation number 2, BD equals to the square root of 16, that is 4, so BD equals to 4 units. So we can write down here that BD equals to 4 units. Okay. In the next step, we will focus on the right triangle ADC. On the right triangle ADC, or by PT is the version for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle ADC. The hypotenuse is AC, so the square of the hypotenuse is AC squared, and it must be equal to the sum of the squares of the perpendiculars. So it must be equal to AD squared plus DC squared. I'll repeat again, the right triangle ADC according to the Pythagoras theorem, AC squared equals to AD squared plus DC squared. So AC squared equals to AD squared. Here AD equals to 3, so AD squared is 3 squared, that is 9, plus DC squared. Okay, here, what is the size of DC? On the drawing, it is very easy to see that DC equals to BC minus BD. BC minus BD equals to DC. So DC equals to BC, that is 6 units, minus BD, that is 4 units. So DC equals to 6 minus 4, that is 2. DC equals to 2 units. And I know that this equals to 2 units. So actually found out that DC equals to 2 units. Therefore DC squared is 2 squared, that is 4. So in conclusion, we found out that AC squared equals to 9 plus 4, that is 13. So AC squared equals to 13. Here we take a root out of this equation, and we found out that AC equals to the square root of 13 units. AC equals to the square root of 13 units. In the next step, we define the center. We define the center of this circle as O. And from point A, we join points A and O together by a straight line. And we'll extend line segment AO by a straight line until it touches the circle. At this point, we'll define the touching point of the extended line segment AD and the circle is point E. So actually, line segment AE or chord AE passes through the center of the circle, passes through point O, that is the center of the circle. Any chord that passes through the center of the circle is defined as the diameter of the circle. So AE passes through the center of the circle, therefore it is the diameter of the circle. AE is the diameter of the circle. In the next step, we'll join points B and D together by a straight line. So we actually created here the peripheral angle, angle ABE. Angle ABE, this angle is a peripheral angle that rests on AE, that is the diameter of this circle, and any peripheral angle that rests on the diameter of a circle must be equal to 90 degrees. Therefore, angle ABE equals to 90 degrees, according to the rule that I mentioned. And we also know that the diameter of any circle is twice as long as the radius, so if the radius of this circle is capital R, then the diameter AE will be equal to 2 times capital R. Okay? And we also have second rule that says that peripheral angles that rest on the same chord are equal to each other. Okay? And according to this rule, actually, those two angles, those two peripheral angles, they both rest on the chord AB, therefore they are equal to each other. Peripheral angle ACB rests on chord AB, and peripheral angle AEB also rests on chord AB, therefore they are equal to each other. So write it down. Peripheral angle AEB, this angle, equals to this angle, peripheral angle ACB. Why? Because both those two peripheral angles rest on the same chord through the AB, therefore they are equal to each other. So if we define angle ACB as theta, angle ACB equals to theta, then from this equation angle AEB equals to angle ACB equals to theta, we derive that angle AEB also equals to theta. Angle AEB also equals to theta. Here, angle AEB, this angle, is also equals to theta. So here we have in the right triangle, triangle ABE, angle AB equals to 90 degrees, angle AEB equals to theta. Therefore, the third angle, angle EAB, must be equal to 90 degrees minus theta in order to complete the sum of the angles in this angle, triangle ABE, 280 degrees. This angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. And exactly for the same reason, here in this angle, triangle ABC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta for the same reason. So in the next step, we will prove that the right ring triangle ABE is similar to the right ring triangle ADC. Why those two right ring triangles are similar to each other? First of all, here, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So for here, angle ABE this angle equals to this angle, this is actually angle ADC, and both angles are equal to 90 degrees. I repeat again, angle AB equals to angle ADC equals to 90 degrees. In addition, those two angles are both equal to theta, therefore they are equal to each other. So here, angle AEB equals to this angle is actually angle ACD. They are both equal to theta, therefore they are equal to each other. Repeat again. Angle AEB equals to angle ACD equals to theta. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So here this angle, angle EAB, equals to this angle, this is actually angle DAC. the above equal to 90 degrees minus theta. Repeat again. Angle EAB equals to angle DAC, and the above equal to 90 degrees minus theta, therefore they are equal to each other. So we found out that all three angles of triangle ABE can go into all three angles of triangle ADC, therefore triangle ABE is similar, this is the sign of similar, to triangle ADC, according to angle similarity rule. Okay, and from the fact that those two right triangles are similar to each other, we conclude that the following equation is true. That AB over AD AB over AD equals to AE over AC. I repeat again. We conclude that AB over AD equals to AB over AD equals to AE over AC. AB equals to 5 units, AD equals to 3 units, AB equals to 2R, and AC equals to the square root of 13 units. Okay, so in conclusion, the formula is according to equation number 2, 5 over 3 equals to 2 times capital R over square root of 13 units. Here we will multiply this equation by square root of 13 units, equation number 3, and we get that according to equation number 3, two times capital R equals to 5 over 3 times square root of 13 units. Here we divide this equation number 3 by 2, and we get that according to equation number 3, the radius of the circle that we are looking for equals to 5 over 6 times square root of 14 units, or in terms of numbers, it is a little bit greater than 3 units. Okay? The radius of this circle that works triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. So we finished with the first method. In the next step I will present to you how to find out the radius of this circle according to the second method. In the second method, we'll use all the things that we already found out that in the first method. First of all, from point A we do perpendicular on BC. So This angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D. We have already found out, according to the first method, that AD equals to 3 units, DC equals to 2 units, and DB equals to 4 units. In the next step, we will extend line segment AD by a straight line until it touches the circle. At this point, we will define the touching point of the extended AD in the circle as point E. Okay. Actually, here we know that AE is a straight line, and we know that the sum of the angles from one side of the straight line equals to 180 degrees. Therefore, this angle must be also equal to 180 degrees. And for the same reason, according to the same rule, that the sum of the angles from one side of a straight line is equal to 180 degrees. So if you focus on this side of the straight line AE, at point D, the sum of the angles must be equal to 180 degrees. So if this angle equals to 90 degrees, then this angle also must be equal to 90 degrees. In order to complete the sum of the angles on this side of the straight line AD to 180 degrees, this angle must be equal to 90 degrees. So all the angles around point D are right angles. In the next step, I will present to you a new rule that is rule number 1. We have already mentioned it in the past. So here, this will be rule number 1. So we have this circle, and here we have called AB. This is called AB. That intersects with called CD. This is called CD. At point O. Point O is the intersection point of chord AB with chord CD. Then according to rule number 1, the following equation is true. Let CO times OD equals to AO times OB. I'll repeat again. If chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. Okay. So I actually can implement rule number 1 in our drawing, because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. Repeat again. BD times DC equals to AD times DE. According to rule number 1, of course. So BD equals to 4 units, DC equals to 2 units, AD equals to 3 units, and DE is the missing line segment, so we leave it as it is. So in conclusion, we found out that according to rule number 1, 4 times 2 is 8, 8 equals to 3 times DE. Here we divide this equation by 3, and we get the DE, the missing line segment, equals to 8 over 3 units. We found out here that DE equals to 8 over 3 units. In the next step, we'll present to you rule number 2. According to rule number 2, if we have this circle, and here we have called AB. This is called AB. That intersects with called CD. This is called CD at 90 degrees. At the intersection point, the two chords rest between them 90 degrees. So all the angles around point O, around the intersection point that is point O, are equal to 90 degrees. So if chord AB intersects with chord CD at 90 degrees, then the following equation is true, that 4 times R squared equals to, here, the length of side AO equals to A units, side OB equals to B units in its length, side CO equals to C units in its length, and side OD equals to D units in its length. Then 4 times R squared, R is the radius of this circle that contains the two chords, then 4 times A squared equals to A squared plus B squared plus C squared plus D squared. Okay? So in our original drawing, we have chord AE that intersects with chord BC at 90 degrees. Therefore, we can implement rule number 2 in our drawing. According to rule number 2, in our drawing we get that 4 times R squared, R is the radius of this circle that contains the two chords, equals to BD squared plus DC squared plus AD squared plus DE squared. Repeat again, according to rule number 2, 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. So 4 times R squared equals to BD squared. BD equals to 4, so BD squared is 4 squared, that is 16, plus DC squared. DC equals to 2, so DC squared is 2 squared, that is 4, plus AD squared. AD equals to 3 units, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 8 thirds, so 8 thirds squared is 64 over 9. So in conclusion, we found out that according to equation number 2, 4r squared equals to 16 plus 4, that is 20, and 20 plus 9 is 29, so it is 29 plus 64 over 9. Here we multiply 29 by 9 and then we divide it by 9 in order to overcome a factor of this expression, and we get that according to 29 times 9 is 261 plus 64 over 9, that is equal to, here 261 plus 64 is 325 over 9. So in conclusion, we found out that 4 times r squared equals to 325 over 9. Here we divide this equation by 4 and we get that r squared equals to 325 over 9 times 4 is 36. So in conclusion, we found out that r squared equals to 325 over 36. We will substitute we will substitute 325 by 25 times 13 equals 25 times 13 equals to 325, so it is over 36. We take a root out of this equation and we get that r equals to the square root of 25 is 5 over 36. The square root of 36 is 6 times square root of 13. So in conclusion, we found out that the radius of this circle that contains that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers it is a little bit greater than 3 units. So we finished with the second method. In the next step I will present to you how to find out the radius of this circle that blocks triangle ABC according to the third method. In the third method, we define angle ABC as theta, and we actually have a formula, special formula to find out the area of any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. The angle between side AB and side AC is theta. The length of side AB is A and side AC equals to B units in its length. Then the area of this triangle ABC, will be equal, according to the new formula, to A times B times sinus theta over 2. Again, the area of this triangle ABC, that could be any triangle, will be equal to A times B times sinus theta over 2. We can implement this formula in order to find out the area of this triangle ABC. Here, so the area of triangle ABC that is equal to 9 units, 9 square units, according to the new formula, will be equal to AB times BC times sinus theta over 2. According to the new formula, the area of this triangle ABC equals to AB times BC times sinus theta over 2. So here 9 equals to AB is 5, BC is 6, times sinus theta is the missing angle over 2. So here, according to equation number 1, we found out that 9 equals to 5 times 6 is 30, and 30 over 2 is 15 times sinus theta. Here we divide this equation number 1 by 3, and we get that according to equation number 1, 9 over 3 is 3, and 15 over 3 is 5. So 3 equals to 5 times sinus theta. Here we divide this equation number 1 by 5, and we get that according to equation number 1, sinus theta equals to 3/5. Sinus theta equals to 3/5. We also have the trigonometric identity. According to the following trigonometric identity, cosine theta equals to the square root of 1 minus sinus square theta. So here, cosine theta equals to the square root of 1 minus, we already found out that sinus theta equals to 3/5. So if sinus theta equals to 3/5, it means that sinus square theta will be equals to 3/5 square. 3/5 square is 3 squared, that is 9, over 5 squared, that is 25. So here cosine theta, that is equal to the square root of 1 minus 9 over 25. Here we multiply 1 by 25, and then we divide it by 25 in order to have a common factor with this expression, and we get that cosine theta equals to 25 minus 9 over 25. So we should found out that cosine theta equals to the square root of 25 minus 9 is 16 over 25. So cosine theta equals to the square root of 16 is 4, or square root of 25 is 5. So in conclusion, we found out that cosine theta equals to 4/5. Cosine theta equals to 4/5. So in the next step, we will implement the law of cosines in our triangle ABC. So I'll repeat shortly of the law of cosines. The law of cosines is true in any triangle. So this is the law of cosines. So if we have triangle ABC, that could be any triangle. This is triangle ABC. Side AB of triangle ABC equals to A units in its length. Side AC of triangle ABC equals to B units in its length, and side BC equals to C units in its length. And the angle between side AB and side AC is theta. Then according to the law of cosines, we will get that cosine theta equals to A square plus B square minus C square over 2 times A times B. I repeat again, this triangle ABC, that will be any triangle. Cosine theta equals to A square plus B square minus C square over 2 times AB. We will implement the law of cosines in our triangle ABC. According to the law of cosines, we get that here cosine theta equals to AB square plus BC square minus AC square over 2 times AB times BC. Okay. Actually, we have already found out that cosine theta equals to 4/5. So we substitute cosine theta by 4/5, and it is equal to AB squared. AB is 5, so AB squared is 5 squared, that is 25, plus BC squared. BC equals to 6 units, so BC squared is 6 squared, that is 36, minus AC squared, over 2 times AB is 5, times BC is 6. Okay? So here we found out that 4/5 equals to 25 plus 36 is 61, minus AC squared, over 6 times 5 is 30, and 30 times 2 is 60. Here we will multiply this equation by 60, and we'll get that 4/5 equals to 4/5 times 60 equals to 61 minus AC squared. Here 60 over 5 is 12, and 12 times 4 is 48. So 48 equals to 61 minus AC squared. Here we will add to this equation AC squared and subtract 48, and we'll get that, according to this equation, AC squared equals to 61 minus 48 is 13, so AC squared equals to 13. We take out of this equation, and we get that AC equals to the square root of 13 units. AC equals to the square root of 13 units. Okay, so I found out here that AC equals to the square root of 13 units. I can write here that AC equals to the square root of 13 units. In the next step, I will present to you a new formula that we use for finding out the radius of any circle that blocks triangle, like in our drawing. So the radius of the circle that blocks triangle ABC, R, equals to the multiplication of the sides of the triangle by each other. In this case is side AB times side AC times side BC. AB times AC times BC over 4 times the area of the triangle that is blocked by the circle. In this case is triangle ABC. Okay. So if I found out that the radius of the circle that blocks triangle ABC equals to the multiplication of the sides of the triangle that is blocked by the circle over 4 times the area of the same triangle that is blocked by the circle. So R equals to the radius of this circle equals to AB, that is 5, times AC, that is square root of 13, times BC, that is 6, over 4 times the area of triangle ABC. The area of triangle ABC equals to 9 units, 9 square units, so this is 9 square units according to what is given as the question. So R, the radius of the circle that blocks triangle ABC equals to 5 times 6 is 30, so it is 30 times square root of 13, over 4 times 9 is 36. So R equals to we divide both the numerator and the denominator on this side of the equation by 6, and we get that 30 over 6 is 5, and 36 over 6 is 6. So it is 5 over 6 times square root of 13 units. So we actually in conclusion found out that the area of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers it is a little bit greater than 3 units. We finish with the third method. In the next step we will summarize the lecture. We will start with the first question. So we have here the big circle that belongs to triangle ABC. AB is the diameter of the big circle. The radius of the big circle equals to 13 units. Triangle ABC blocks the small circle. The small circle is described by triangle ABC. And the radius of the small circle equals to 4 units. And we want to find out the shape and the area of the blue shape. So first of all, we define the center of the small circle as O. We define the point of tendency of tangent CB with the small circle as M. We define the point of tendency of tangent CA with the small circle as N, and we define the point of tendency of tangent AB with the small circle as L. Then we join points O and M together by a straight line. O is the center of the small circle. M is the point of the small circle itself. So this is exactly the definition for radius. So OM is the radius of the small circle. It is equal to 4 units. Likewise, we join points O and N together by a straight line. O is the center of the small circle, N is the point of the small circle itself. Therefore, ON is also the radius of the small circle that is equal to 4 units. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency B with this small circle. Whenever we have a radius that is drawn to the point of tendency, then tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO, that is to say this angle was 90 degrees, and this angle will also equal to 90 degrees according to rule number 1. Likewise, we have the radius ON that is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO, that is to say this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to rule number 1. And we also have the rule that any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So here we have the peripheral angle ACB, this angle ACB that rests on AB, that is the diameter of the big circle, therefore it is equal to 90 degrees according to the rule that I mentioned. So here in quadrilateral ONCM we have 1, 2, 3 right angles. Okay. And the sum of right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle MON. This angle, in total the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle, this angle, angle MON, equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. This angle equals to 90 degrees, so actually inside quadrilateral MOAN we have 4 right angles. And then the quadrilateral of those 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral ONCM as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other, so the opposite sides of rectangle ONCM must be equal to each other. That is to say, ON equals to CM. ON equals to CM. But we already found out that ON equals to 4 units. It is the radius of the circle. So ON equals to 4, and from this equation 4 equals to ON equals to CM, we've derived that CM is also equals to 4 units. Here CM equals to 4 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we'll get that OM equals to NC. OM equals to NC, but we have already found out that OM equals to 4 units. It is the radius of the small circle. So here OM equals to 4 units, and from this equation 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. Here NC equals to 4 units, so we actually found out that all the sides of quadrilateral ONCM are equal to each other. Therefore, quadrilateral ONCM, it is not a rectangle but a square. Then we define side AC as A, side AB as C, and side CB as B. Here, AC equals to A, CB equals to B, and AB equals to C according to our definition. So what is the length of side AN? AN equals to CA minus CN. CA minus CN equals to AN. N equals to CA minus CN, so AN equals to CA, CA equals to A, minus CN, that is 4. So in conclusion, we found out that AN equals to A minus 4. Likewise, we found out the length of line segment MB. From the domain, it is very easy to see that MB equals to CB minus CM. Again, CB minus CM equals to MB. Yeah. MB equals to CB minus CM. So MB equals to CB, CB is B, and CM is 4. So in conclusion, we found out that MB equals to B minus 4. MB equals to B minus 4. Then I presented to you rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Again, the lengths of two tangents from a common external point to a circle are equal. So we focus on the common external point, point A. From the common external point, point A, we have two tangents to the small circle, tangent AN and tangent AN. According to rule number 2, they are equal to each other. Here, AN equals to AN according to rule number 2. But we have only found out that AN equals to A minus 4. Here. Actually, here. AN, we only found out that AN equals to A minus 4. AN equals to A minus 4, and from this equation, AN equals to A minus 4, we derive that AN is also equals to A minus 4. Here, AN equals also to A minus 4. Then we focus on the common external point, point B. From the common external point, point B, we have two tangents to the small circle, tangent BM and tangent BM. And according to rule number 2, they are equal to each other. So BN equals to BM according to rule number 2. But here we have already found out that BM equals to B minus 4. Here BM equals to B minus 4. And from this equation, BN equals to BM equals to B minus 4, we derive that BN is also equals to B minus 4. Yeah. BN is also equals to minus 4, to B minus 4. So we found out that BN equals to B minus 4, and AN equals to A minus 4. Okay. We know that AB is the diameter of the big circle, and the diameter of any circle is twice as long as the radius. So if the radius of this circle is capital R, then the diameter of the circle AB must be equal to 2 times R, 2 times capital R. It is given us the question that capital R equals to 13 units, therefore 2 times R is 2 times 13, that is 26. So here C, that is also equal to AB, equals to 26 units. That is to say that the diameter of the circle equals to 26 units. So for one side, the diameter AB equals to 26 units, but from the other side, the diameter AB from the domain, it's very easy to see that AB equals to AL plus LB. AB equals to AL plus LB, but here AL equals to A minus 4. AL equals to A minus 4, and BL equals to B minus 4. So BL equals to B minus 4. So in conclusion, we found out that 26, that is the diameter, equals to the diameter AB of the circle equals to A minus 4 plus B minus 4. That is to say, according to equation number 1, 26 equals to A plus B, minus 4 plus minus 4 is minus 8. So 26 equals to A plus B minus 8. We added to this equation 8, and we found out that A plus B equals to 26 plus 8 is 34. We squared both sides of equation number 1, and we found out that A plus B squared equals to 34 squared. We opened the brackets on both sides of equation number 1, and we found out that A plus B squared equals to A squared plus B squared plus 2 times AB, and it is equal to 34 squared. 34 squared is 1156. Then we focused on the right triangle, triangle ABC. According to the Pythagoras theorem of the right triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AB. So the square of the hypotenuse is AB squared, that is equal to AC squared plus CB squared. Here AB squared equals to AC squared plus CB squared. So AB squared equals to AC squared. AC is A, so AC squared is A squared plus CB squared. CB equals to B, so CB squared is B squared. CB squared is B squared, so in conclusion we found out that AB squared equals to A squared plus B squared, but AB equals to C, according to our definitions. So we substitute AB by C, and we got that C squared equals to A squared plus B squared. But we have only found out that C equals to 26, so C squared is 26 squared. 26 squared is 676, that is equal to A squared plus B squared according to equation number 2. And because of the fact that A squared plus B squared equals to 676, it means that we can substitute A squared plus B squared in this equation number 1 by 676. We did it, and we got it according to equation number 1. A squared plus B squared is 676 plus 2AB, that is equal to 1156. We subtracted 676 from this equation number 1, and found out that 2 times AB equals to 1156 minus 676, that is 480. So according to equation number 1, we found out that 2 times AB equals to 480. We divided this equation number 1 by 2, and we found out that 2 times AB over 2 is AB, and AB equals to 480 over 2, that is 240. So, according to equation number 1, A times B equals to 240. We divided this equation number 1 by 2, and found out that AB over 2 equals to 240 over 2, that is 120. So we found out, in conclusion, that A times B over 2 equals to 120. So what is the area of the blue shape? From the drawing, it is very easy to see that the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. Okay, so the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. The area of triangle ABC equals to the base of the triangle, that is AC, times the height to the base, that is CB over 2. So it is AC times CB over 2 minus the area of the small circle. The area of the small circle equals to pi r square, when r equals to 4 units. So it is pi r square. And the area of triangle ABC equals to AC times CB over 2. But AC equals to A, BC equals to B. So in conclusion, AC times CB over 2 equals to A times B over 2. minus pi r squared. R equals to 4, so r squared is 4 squared is 16, so the small circle equals to 16 pi. But we have already found out also that AB over 2 equals to 120, so we can substitute AB over 2 by 120. We did it and we got that the area of the blue circle in conclusion equals to 120 minus 60 pi square units, so in terms of numbers, it is equal to 69.73 square units. We finished with the first question, then I presented to you the second question, and we solved the second question in 3 different methods. In the drawing, we have this circle, and the circle blocks triangle ABC, or triangle ABC is inscribed by this circle. You know that the area of triangle ABC equals to 9 square units, side AB triangle ABC equals to 5 units, side BC equals to 6 units. And we want to find out the area of this circle that blocks triangle ABC. So, first of all, we made a construction from point A. We drew perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So we actually know that the area of triangle ABC equals to 9 square units. And the area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is AD over 2. So it is BC times AD over 2. BC equals to 6 units times AD over 2. 6 over 2 is 3, so in conclusion we found out that according to equation number 1, 9 equals to 3 times AD. We divided equation number 1 by 3 and we found out that AD equals to 9 over 3, that is 3. Then we focused on the right triangle, so here AD equals to 4 units. Then we focused on the right triangle, triangle ABD. According to the Pythagoras theorem, AB square equals to AD square plus BD square. AB square equals to AD square plus BD square. So AB is 5, so AB square is 5 square, that is 25, equals to AD square. AD is 3, so AD square is 3 square, that is 9, plus BD square. So here we subtracted 9 from this equation, and found out that 25 minus 9 is 16, so 16 equals to BD square. We took the root of this equation, equation number 2, and found out that BD equals to the square root of 16, that is 4. So here BD equals to 4 units. Then if BD equals to 4 units, then what is the length of DC? Here, it is very easy to see from the drawing that DC equals to BC minus BD. Here, DC equals to BC minus BD. BC equals to 6 units, BD equals to 4 units. So in conclusion, we found out that DC equals to 2 units. Okay? So here, 9 segment DC equals to 2 units. Then we focus on the right triangle, right green triangle, triangle ADC. We implemented the Pythagoras theorem on this green right triangle. According to the Pythagoras theorem, AC square equals to AD square plus DC square. AC square equals to AD square plus DC square. AD is 3, so AD square is 3 square, that is 9, plus DC square. DC is 2, so DC square is 2 square, that is 4. So in conclusion, we found out that AC square equals to 9 plus 4, that is 13. So if AC square equals to 13, we took a root out of this equation and found out that AC equals to the square root of 13 units. Here AC equals to the square root of 14 units. Then we define the center of this circle as O. And from point A, we join points A and O together by a straight line. Then we extended 9 segment AO by a straight line until it touches the circle at this point, point E. So because of the fact that chord AE passes through the center of the circle, it must be the diameter of this circle. So AE is the diameter of the circle, that is to say it is equal to 2 times the radius of this circle, that is 2 times capital R. Okay, then we join points B and D together by a straight line. join points B and E together by a straight line. We created a peripheral angle ABE. Peripheral angle ABE rests on AE, that is the diameter of the circle. Therefore, any peripheral angle that rests on the diameter of a circle equals to 90 degrees. So peripheral angle ABE that rests on AE, that is the diameter of a circle, must be equal to 90 degrees. So angle AB equals to 90 degrees. Then we have another rule that states that peripheral angles that rest on the same chord are equal to each other. So if we focus on chord AB, we have two peripheral angles. Those two peripheral angles are both rest on the same chord AB. Therefore, they are equal to each other. So here, peripheral angle AB equals to peripheral angle ACB because of the fact that both peripheral angles rest on the same chord AB. So if we define angle AEB as theta, then from this equation, if we define angle ACB as theta, here, this angle ACB is theta, then angle ACB equals to theta, then from this equation angle AEB equals to angle ACB equals to theta, we will derive that angle AEB is also equals to theta. Here, this angle AEB equals to theta. Okay? Then so this angle equals to 90 degrees. This angle equals to theta. This angle must be equal to 90 degrees minus theta in order to complete the sum of the angles at angle ABE to 180 degrees. This angle must be equal to 90 degrees minus theta. For the same reason, this angle must be also equal to 90 degrees minus theta. Then we prove that the two great angles are similar to each other. Why they are similar to each other? First of all, those two angles are equal to each other, they are equal to 90 degrees. Those two angles are both equal to theta, therefore they are equal to each other. Those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we prove that all the angles of triangle AB can go into all the angles of triangle ADC. Therefore, triangle AB is similar to triangle ADC according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will derive that AB over AD equals to AE over AC. AB over AD equals to AE over AC. AB is 5, AD is 3, AE is 2 times capital R, that is the diameter of the circle, and AC equals to square root of 13 units. Okay, so here we multiply, so we got that 5 over 3 equals to 2R over square root of 13 units. We multiply this equation by square root of 13 units, and we found out that according to equation number 3, 2 times the radius of the circle equals to 5 over 3 times square root of 13. We divided this equation by 3 and we found out that the radius of the circle that we are looking for equals to either 5 over 6 times square root of 13 units, so in terms of numbers, it is a little bit greater than 3 units. Okay, so we finish with the first method. Then I presented to you how to find out the radius of this circle that belongs to triangle ABC according to the second method. In the second method, we use the fixed that we have already found out in the first method. So here from point A we draw perpendicular on BC. This angle equals to 90 degrees and this angle equals to 90 degrees according to our definition. We define the touching point of the perpendicular from point A and BC as D. AD equals to 3 units, DC equals to 2 units, and DB equals to 4 units according to the first method. Then we extended line segment AD by a straight line until it touches the circle at point E. Then I presented to you rule number 1. According to rule number 1, if chord AB intersects with chord CD at point O, then CO times OD equals to CO times OD equals to AO times OB. We can implement rule number 1 in our drawing. Why? Because in our drawing we have chord AE that intersects with chord BC at point D. Therefore, according to rule number 1, we get that BD times DC equals to AD times DE. Again, according to rule number 1, we get that BD times DC equals to AD times DE. BD is 4, DEC is 2, AD is 3, and D is the missing 9 seconds. So 4 times 2 is 8. So 8 equals to 3 times DE. We divided this equation by 3 and we found out that D equals to 8 over 3 units. DE equals to 8 over 3 units. Then I presented to you rule number 2 and implemented rule number 2 in our drawing. According to rule number 2, if chord AB intersects with chord CD at 90 degrees, if chord AB intersects with chord CD at 90 degrees, then the following equation is true, that 4 times A squared equals to A squared plus 4 times R squared. R is the radius of this circle that contains the two chords. 4 times R squared equals to A squared plus B squared plus C squared plus D squared. Okay, we can implement rule number 2 in our drawing, because in our drawing we have chord AE that intersects with chord BC at 90 degrees. All the angles around point D are equal to 90 degrees, therefore we can implement rule number 2 in our drawing. According to rule number 2, we'll get that 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. Repeat again. 4 times R squared equals to BD squared plus DC squared plus AD squared plus DE squared. So 4 times A squared equals to BD squared. BD is 4, so BD squared is 4 squared, that is 16. DC plus DC squared. DC is 2, so DC squared is 2 squared, that is 4 plus AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus DE squared. DE is 8 over 3, so DE squared is 64 over 9. So in conclusion, we found out that 4R squared equals to 16 plus 4, that is 20, and 20 plus 9 is 29. So it is 29 plus 64 over 9. Here we multiplied 29 by 9 and then we divided by 9 in order to have a common factor of this expression. 29 times 9 is 261 plus 64 over 9. 261 plus 64 is 325 over 9. So in conclusion, we found out that 4 times R squared equals to 325 over 9. We divided this equation by 4 and we found out that R squared equals to 325 over 4 times 9, that is 36. So R squared equals to 325 over 36. We substituted 325 by 25 times 13, and then we took a root out of this equation and we found out that the radius of the circle that we are looking for, it is equal to either to square root of 25 is 5 or square root of 36 is 6, so it is R equals to 5 over 6 times square root of 13 units, so in terms of numbers it is a little bit greater than 3 units. Okay, we finished with the second method. Then I presented to you how to find out the radius of the circle that blocks triangle ABC according to the third method. In the third method, we defined angle ABC as theta, and I presented to you a new formula. According to this formula, we can calculate the area of any triangle. So here we have triangle ABC that could be any triangle. The angle between side AB and side AC is theta. Side AB equals to A units in its length, side AB equals to B units in its length, side AC equals to B units in its length, side AB equals to A units in its length. Then the area of triangle ABC equals to this triangle ABC equals to A times B times sinus theta over 2. Again, the area of this triangle ABC equals to A times B times sinus theta over 2. Okay? So use this formula in order to calculate the area of our triangle ABC. According to the formula that I showed to you, the area of this triangle ABC will be equal to AB times BC times sinus theta over 2. The arc triangle ABC equals to AB times BC times sinus theta over 2, but we know that the arc triangle ABC equals to 9 square units. It is given as the question. So here 9 equals to AB, that is 5, times BC, that is 6, over sinus theta over 2. So 9 equals to 5 times 6 is 30, and 30 over 2 is 15. So 9 equals to 15 times sinus theta. We divided this equation by 3 and we found out that 9 over 3 is 3 and 15 over 3 is 5. So in conclusion, according to equation number 1, we found out that 3 equals to 5 times sinus theta. We divided this equation by 5 and we found out that sinus theta equals to 3/5. Then we have the trigonometric identity that cosine theta equals to the square root of 1 minus sinus square theta. So here cosine theta equals to 1 and sinus theta equals to 3/5. So therefore sinus square theta will be equal to 3/5 squared. 3/5 squared is 3 squared, that is 9, over 5 squared, that is 25. So here, if cosine theta equals to 1 minus sinus square theta, then cosine theta equals to 1, and we already found out that sinus square theta equals to 9 over 25. Then we substituted 1 by 25. We multiplied 1 by 25 and then we divided by 25 in order to overcome the factor with this expression, and we found out that cosine theta equals to 25 minus 9 over 25. 25 minus 9 is 16 over 25. So cosine theta equals to the square root of 16, that is 4, over square root of 25, this is 5. So in conclusion, we found out that cosine theta equals to 4/5. Okay, then I presented to you the law of cosines, and we implemented the law of cosines in our triangle ABC. What is the law of cosines? The law of cosines is true in any triangle. So if we have this triangle ABC, that could be any triangle, side AB equals to units, side AC equals to B units, and side BC equals to C units, then and the angle between side AB and side AC is theta, then cosine theta equals to A square plus B square minus C square over 2 times AB. So in our triangle ABC, according to the law of cosines, we get that here cosine theta equals to AB square plus BC square minus AC square over 2 times AB times BC. Cosine theta equals to AB square plus BC square minus AC square over 2 times AB times BC. Okay, we already found out that cosine theta equals to 4/5. AB is 5, so AB square is 5 square, that is 25. BC is 6, so BC square is 6 square, that is 36. Minus AC square over 2 times AB is 5 and BC is 6. So here 4/5 equals to 25 plus 36 is 61 minus AC square. So in conclusion, 4/5 is equals to 61 minus AC square over 60. We multiplied this equation by 16 and found out that 4/5 times 60 equals to 61 minus AC square. Here 60 over 5 is 12, and 12 times 4 is 48. So in conclusion, we found out that 48 equals to 61 minus AC square. We added to this equation AC square and also subtracted 48 simultaneously, and we found out that AC square equals to 61 minus 48 is 13. So AC square equals to 13. We took a root out of this equation and found out that AC equals to the square root of 13 units. So here AC equals to the square root of 13 units. And then I presented to you a new formula that by this formula we can find out the radius of any circle that blocks triangle. Okay, the radius of any circle that blocks triangle equals to the multiplication of the sides of the triangle equal to the multiplication of the sides of the triangle by each other. In this case, we have this circle that blocks triangle ABC. So the multiplication of the sides of triangle ABC is AB times AC times BC, AB times AC times BC over 4 times the area of triangle ABC. It is over 4 times the area of triangle ABC, and the area of triangle ABC equals to 9 square units, so it is 4, so the area of triangle ABC equals to 9. AB equals to 5, AC equals to square root of 13 units, and BC equals to 6. Over 4 times the area of triangle ABC is 9. 5 times 6 is 30, so it is 30 times square root of 13, and 4 times 9 is 36. So R equals to 30 over 36 times square root of 13. We divided both the numerator and the denominator of this side of the equation by 6, and we got that R equals to 30 over 6 is 5, and 36 over 6 is 6. So in conclusion, found out that the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, repeat, the radius of this circle that blocks triangle ABC equals to either 5 over 6 times square root of 13 units, or in terms of numbers, it is a little bit greater than 3 units. Okay, thank you very much.